Hello everyone. In this lecture we will discuss about the counter current heat exchanger. There is a problem that propane gas is at 40 degrees centigrade and 250 kilopascal enter a continuous adiabatic heat exchanger where no heat is lost from outside of the unit while heat is transferred between streams. The stream exit at 240 degrees centigrade. The flow rate of propane is 100 mole per minute and the superheated steam at 5 bar and absolute pressure and the superheated steam at 5 bar absolute pressure and 300 degrees centigrade enter the heat exchanger with a flow rate of 6 kg per hour. The steam exits the heat exchanger at 1 bar absolute pressure. Calculate the temperature of the exit steam. So propane gas at 40 degree and 2 kilopascal enter a heat exchanger and there is no heat transfer between the heat exchanger and surrounding. The exit steam temperature is 40 degree and the flow rate of propane is given to us. The superheated steam at 5 bar and 300 degrees centigrade enter the heat exchanger at a flow rate of 6 kg per hour. The steam exit the heat exchanger at this temperature, and what will be the temperature of the exit steam? So we will define the we will calculate the temperature of the exit steam with the help of spanheises. So we will go to the spanheises. There are two components, one is propane and the second one is the steam. So we can add, one is propane and the second one is steam. So these are the components. Click on fluid package and click on add. So these are various fluid package. I am using the Chow seeder. This is okay. Now this is the solubility and eccentricity of the propane and water, and then we will go to the simulation. So in the simulation environment will open, and here we will add a heat exchanger. This is the heat exchanger. Click on the heat exchanger. It is okay. Now close this one and double click on the heat exchanger. So this is the tube inlet, tube outlet, and this is the shell inlet and the shell outlet. So here you can see that propane at 40 degree and 250 kilopascal enter a adiabatic heat exchanger with no heat loss from. So propane is entering into the shell side of the heat exchanger. So this is the shell side, propane in, and this is the shell out. Propane out, and the steam inlet, steam is entering into the tube side. So steam in, and the steam out. Now it shows unknown delta P. So now we will go to the worksheet, and here this is the steam in, steam out, propane in, propane out. So the propane inlet temperature and pressure are given to us. The propane inlet temperature is 40 degree and 250 kilopascal. So the propane inlet temperature is 40 degree and 250 kilopascal, 40 degree centigrade, and the pressure of propane is 250 kilopascal. Okay. Now the propane enter at 40 degree and 2 kilopascal enter continuous adiabatic heat exchanger. No heat loss from outside of the unit. The stream exit at 240 degrees centigrade. So the outlet temperature of propane is 240 degrees centigrade. So the propane outlet temperature is 240 degrees centigrade. Outlet temperature is 240 degrees centigrade. 240 degree centigrade. Propane outlet temperature is 240 degrees centigrade. The stream outlet temperature is 240. The flow rate of propane is 100 mole per minute. So the molar flow rate of propane is given 100 mole per minute. Propane molar flow rate, propane in, and the molar flow rate of propane is this one, 100 mole per minute. 100 mole per minute. mole per minute, 100 gram mole per minute. It is okay. 6, it is equal to 6 kilogram mole per hour. Propane inlet molar flow rate is 100 mole per minute, and superheated steam at 5 bar absolute pressure and 300 degree enter the heat exchanger. So superheated steam at 5 bar and 300 degree centigrade. So the steam is entering at 300 degree centigrade. 300 degree centigrade, this is superheated steam, and it is entering to the heat exchanger at 5 bar. 5 bar and 300 degree centigrade. 5 bar, so it is equal to 500 degree, 500 kilopascal. It is equal to 5 bar. It is okay. Now the molar flow rate, the mass flow rate of the steam is 6 kilogram per minute. So 6 kilogram per minute, mass flow rate of the steam is 6 kilogram per minute, 6 kilogram per minute, which is equal to 360 kilogram per hour. So now the steam exits the heat exchanger at 1 bar absolute pressure. The out 1 bar absolute pressure. The outlet pressure of the steam is 1 bar. 1 bar, which is equal to 100 kilopascal. 1 bar. So the steam outlet pressure is 1 bar absolute pressure. So this is okay. Now what is the outlet temperature? So what will be the outlet temperature of the steam? What will be the outlet temperature of the steam? So it shows unknown delta phi. It shows unknown delta phi. So the pressure of this is the pressure of the steam inlet, steam outlet, and the propane inlet pressure is 250 kilopascal. There is no pressure drop in the shell side, so I am assuming 250 kilopascal is in the outlet. So now it shows the unknown composition. So go to the composition, and here this is the steam in. So the steam is only water. It is pure steam. So this is okay. Steam. So the steam inlet and steam outlet. There is no propane in the steam, and the propane. This is the propane inlet. It is pure propane. There is no water or no steam. So this is okay. One mole fraction. This is okay. Now the correction factor is too low. So we will go to, this is the heat exchanger, this is the tube passes. So I'm changing the tube passes from 2 to 1 passes. Okay, now it is okay. Now go to the performance. This is the performance, and this is the, go to the condition, and here you can check the steam outlet temperature is 133 degrees centigrade. So the outlet temperature of the steam which is leaving the heat exchanger is 133 degrees centigrade. So now here you can also plot, this is the duty of the heat exchanger, 1.16 multiplied by 10 to the power 5 kilojoule per hour. This is the heat loss, and this is the FT factor 1, and also the plot. Click on plot. So this is the pressure versus temperature plot. So on the x-axis this is the temperature, this is the pressure. The blue one is for the tube side, and this is for the shell side. In the shell side there is no pressure drop in the shell side, you can check it. So I'm changing it to enthalpy or heat flow. So temperature versus heat flow. This is the temperature versus heat flow for the shell side, for the tube side, and this is the temperature versus the heat flow across the tube, the shell side. This is the shell side, and this is the tube pass. The tube side. This is the table. This is the correct vapor fraction. This is the enthalpy, temperature, pressure. So here is the dynamic, the tube volume, the overall heat transfer. This is the heat transfer coefficient, overall heat transfer coefficient, the shell volume, and this is the tube. This is the, so you can check that the temperature of the outlet steam is 133 degrees centigrade. Thank you very much for your attention. If you are new to the channel, please like and subscribe.